Hello children, how are you all? So children, we are again into the atoms and molecules. What have we learned in the past? Okay, right, we have learned about Dalton's atomic theory. Later on, we also have learned about that which is related to Dalton's atomic theory, which is called as the atomic mass. Now, what is atomic mass? We have seen it is very difficult to find or to make a measurement of an atom of an element. That is, you can measure, but when you compare it to a gram, when you express that in gram, it's such a small number, it's a fraction, and that's very tedious or difficult to remember, also to write. So children, the purpose goes lost when we can't remember that in the calculations required. So okay, children, what scientists have done is to find the atomic masses in terms of the atoms itself. That is, they have chosen units which are very, very less, and they are comparable to the atoms masses. Okay, so what are those? So they are called the atomic mass units. Now, okay, right, at different times they have chosen different atomic mass units, right? Okay, gram becomes very big, so they have chosen a certain unit of mass, like they have considered certain atoms of elements like oxygen, right? And they have taken 1/16 of the oxygen's mass, oxygen atom's mass, as the standard atomic mass unit. And then next, any atom's mass was compared to that, and that gave us a whole number. So children, that becomes atomic mass. That whole number becomes atomic mass of that particular element, which gives us an idea about how much the mass of the atom is compared to 1/16 mass of oxygen atom. Later on in 1961, we have seen that 1/12 of the mass of a carbon-12 isotope atom, that was chosen as a standard atomic mass unit. And later on, this was called atomic mass unit. Later on, the unit's name was changed to unified mass unit, right? And then next, now, so how did people find the atomic mass, children? So they have divided the mass of the atoms with the mass, that mass of the atoms in grams, with that of 1/12 mass of carbon-12 isotope, and they get what is called the relative atomic mass as whole numbers. So children, they have found the masses like this. Now we are going to talk about another aspect which Dalton's theory would tell. So atoms are there, and what are these atoms doing? They are always trying to combine and form what are called as compound atoms, which we are calling now as molecules. Now, why are atoms combining? Now, why are atoms combining, or how are atoms? For your information, children, atoms are always trying to combine, right? Atoms are not freely available. They are not having a free existence. They don't exist independently, usually, most of them. What is the reason? That is because of their electronic configuration, which we have learned. So what is electronic configuration, children? The systematic arrangement of the electrons in different levels of the atom. We call them as the electronic configuration, is it not? Yes. So children, right, now why do atoms combine? What happens when they combine? They form molecules. What are molecules? So they are a combination of atoms with a force of attraction between the atoms, which is called as a bond or a chemical bond. So atoms, they combine to form what are called as molecules. So children, let us go into the details of what is called molecules. Right, so we have molecules now. Okay, right, children. So we have seen the reason why atoms combine. Atoms combine in order to form molecules, but that is not the actual reason why atoms combine. But what is the reason? So children, look here, children. We have talked about electronic configuration. There are some elements. There are some elements which are called as inert elements. Okay, children, inert elements. Now, okay, when you carefully observe these inert elements like helium, neon, argon, krypton, and xenon, we find that this is 2, the atomic number is 2, then the atomic number is 10 here, the atomic number is 80, the atomic number here is 36, and xenon it is 54. Right. So Okay, right. So children, when we write the electronic configuration is K, L, M, N shells. K shell, there are two complete. That shell is completely filled here, and that is 2, 8. This configuration is 2, 8, 8. We have both Bury skin fulfilled here, and 2, 8, 8, and then next 18, and 8, okay, 18, 26, 36, right, and it is 2, 8, that's 18, 18, and 8. So children, you observe something careful here. So you find that the last orbits of these neon, argon, krypton, xenon, they have a special electron configuration, which we have understood that they are called as the octet configuration. So this octet configuration is something special that is making atoms of these elements, to remain unreactive or inert. So children, so these elements, the atoms of these elements are not reacting. So what is the reason for it? That's because of the octet. So they are inert. What inert? Inert means inactive or not chemically active. So children, this is the reason. Now, okay, helium, it is a special case where the first shell is completely filled. So that is the reason why children, we find that helium also is an inert gas. So children, all these are gases, and as they are not involving in any chemical reactions by themselves, so they are called as inert gases. What are they called, children? Inert gases or inert elements. Okay, they are inert gases. Okay, very fine. So these are all inert gases. Now, okay, what about other elements? Why do other elements react? So children, when I write down, say, the example of sodium. So we have learned all these things in the structure of atom, children. And if I write down the electronic configuration of sodium, its atomic number is 11, and the electronic configuration is 281. Now, just very carefully observe this. Okay, right. So that electronic configuration resembles the configuration of neon. So it wants to lose this one electron and form what is called as the electronic configuration of neon. So its outermost shell, that is the second shell, is having 8 electrons, and that is the reason why sodium wants to lose one electron. When it loses an electron, what happens is now sodium also will get what is called 2,8 configuration. Right, okay. So this sodium now gets the configuration of neon, and due to which it also becomes stable. But in this process, sodium actually having now 11 atomic number means there are 11 protons, and it will have an equal number of electrons, right? Good. So its charge actually should be 0, right? Because atom initially is neutral, right? Good. Then next, if it loses one electron, it becomes 10 electrons, and that's 11 positive charges that will become right, children, to become +1. So thus sodium atom, it becomes positive. So that is what is called an ion. So we know well that is called as a positive ion. So it is a positive ion, and it's also called as cation. So a cation is formed. An atom is now becoming a charged atom. So this charged atom, we call it as a cation. So children, right, and similarly, if I go to understand, say, the configuration of chlorine. Chlorine, its atomic number is 17. Okay, children, right, okay, 17 is electronic configuration is 287. You just check this. There is no octet here. So this chlorine atom, it wants to get one electron from somewhere outside, wherever it is being provided, and under certain conditions, and results in getting the configuration of 288. But chlorine, it is having 17 protons and 17 electrons, and that results in a neutral atom actually. But as it gains one electron, it becomes -18. That becomes -1. So that makes chlorine negatively charged atom. That is called as an anion. So what is that, children? A negatively charged ion, we call it as anion. So thus we find that ions are formed. Now what happens between these ions? So during these ions, the oppositely charged parts, they will attract together to form what is called a molecule. So to, like, not only that way, but there are different ways in which atoms can combine to form what are called molecules. We will be talking about a new one. So children, say if a sodium and chloride ions, they combine, they are coming closer. That results in formation of a particle which is called as a simple a unit which is called as sodium chloride. This is our common salt, and the sodium ions, chloride ions, they combine and form a large complex structure actually, which is called as lattice, crystal lattice for your information. So children, atoms combine to form molecules. So molecules are the things which are free, and atoms are not independent. So when atoms are combining, they are doing so with a purpose, that is to become like inert gases. We say that atoms are trying to become stable by combining and forming molecules. So children, atoms are not free always, but there are some atoms of some elements which are free or independent. These are called as the inert gases. Their atoms are free, but the atoms of other elements, they're always trying to combine with other elements to come to an understanding of either giving electrons or taking electrons. Sometimes there is a process of sharing electrons also, and result in a unit which is called as a molecule. So atoms combine to form molecules in order to become stable. Stable means getting the configuration of inert gases. So children, the sole purpose of atoms becoming molecules is to make what is called as stability possible. So we'll now move to the types of molecules, children. Molecules of elements and molecules of compounds. How are these formed? That is what we will try to understand. So children, right, we find that the atoms of inert gases, they are quite stable because they have something called as a octet configuration, so they can exist independently. But why are other atoms combining? So we have seen just why that the reason for other atoms combining to form or trying to combine to form molecules is only one reason, that is they are trying to get the configuration of inert gases. Right, okay. So children, right, they try to get inert gas configuration, that is either 8 electrons in their outermost orbit, which is octet, or in the case of helium it is duplet configuration. Right, okay. And atoms of other elements, they combine to form molecules to get the configuration of different elements we have seen. Now the molecule formation can take place in two different ways, that is the electrons between the atoms can be shared. Okay, there will be give and take, or otherwise both of the atoms of the elements involved, they can share the electrons and result in the formation of what is called as a covalent bond. The force of attraction due to sharing of electrons is called as a covalent bond. So atoms can combine to form molecules with a covalent bond, and atoms sometimes they exchange electrons, that is one atom of an element can give electrons to the other atom, and the other atom receives it. During this process ions are formed, so that is the atom which loses electrons. Just now we have seen in the case of sodium and chlorine, sodium atom, it is losing electrons, it is becoming positively charged ions, which are called as what are called as cations, and the chlorine ion, chlorine atom, it is gaining that electron as becoming chloride ion. So children, which is negative, so that's called as anion. So these positively charged and negatively charged ions, they come together and form what is called as ionic bond. So there are two ways in which atoms combine to form molecules. Right, that is by sharing of the electrons, or by transfer of electrons from one atom of an element to the atom of the other element. So children, that's how. And what are the different types of molecules? So children, both atoms of elements, they combine among themselves. to form molecules, and atoms of other elements, that is different elements, also can combine to form molecules. Now, how are atoms of same element combining to form molecules? So naturally, as they are same type of elements, same type of atoms, they combine in usually what is called as a covalent bond, that is they share and form what are called individual molecules. So now, what are these molecules? Molecules are independent entities of a substance, of a compound or an element. So children, the next one, what are molecules? So that's what we are talking about. Atoms are combining to form molecules. What is the reason? They want to become stable. So what do you mean by stability? So they are no more going to react with other things. So they are quite stable in themselves, or quite satisfied in themselves. So children, right, these molecules, they can exist independently. So molecules can be defined as those particles in a compound or an element which have the ability to exist independently, or which are capable of independent existence. So what is a molecule? A molecule of any substance, either an element or a compound, is that entity which has the independent existence. So children, this is a molecule, right? Okay, next, and there are also molecules of compounds. So children, we have seen molecules of elements. What are the atoms of the same element? They combine to form molecules. So they are called the molecules of elements. Like you can see, children, there's hydrogen molecule consisting of 2 atoms of hydrogen, and the oxygen molecule consisting of formed by combination of 2 atoms of oxygen, and chlorine, that is formed by combination of 2 atoms of chlorine and fluorine and phosphorus. You can see that in phosphorus there are 4 atoms of phosphorus combining and forming 1 molecule of phosphorus, and similarly sulfur, that is 8, it is consisting of 8 molecules, 8 atoms combining to form 1 molecule of sulfur. So children, so these are the things. And the next one, you can see that molecules of compounds. Now, why are these? How are these molecules of compounds formed? Atoms of different elements are combining to form what are called as molecules of compounds. Here we can see that atoms of same element are combining, so they are molecules, but they are molecules of elements. And here the molecules are formed by the combination of atoms of different elements. You can see, children, in water there are atoms in water molecule. Each water molecule there are 2 atoms of hydrogen and 1 atom of oxygen, right? Okay, so children, this is how the molecule of water is formed. So you can find atoms of 2 different elements there. And similarly, we can see carbon dioxide. There we have 1 atom of carbon and 2 atoms of oxygen. So this is the molecule of carbon dioxide formed from atoms of 2 different elements, that are carbon and oxygen. And the next one we have seen, we see ammonia. Ammonia is the molecule of ammonia is a compound, and the molecule of this compound is formed by atoms of the combination of the atoms of 2 different elements, nitrogen and hydrogen. So children, molecules are 2 types. What are the molecules of elements and molecules of compounds? So just generalize one thing, that molecules are formed by atoms, and atoms, they combine because they are not stable. So when they are combining the molecules, they are actually attaining the stability. So that is, they are getting the configuration of inert gases. So children, we have 2 types of molecules: molecules of elements and molecules of compounds. How are these molecules formed? There are ways in which the molecules can be formed. That is, one by complete transfer of electrons, the other one is by sharing of electrons. That which is formed by sharing of electrons, we call it as covalent bond formation between the atoms, and the other one which is formed by transfer of electrons between the atoms, so that is called as a ionic bond. So children, these ionic bond and covalent bond you'll be learning in detail in your next class, that is class 10. Okay children, right, now we are going to talk about atomicity. What is atomicity, right? So children, right, we are going to learn about atomicity, right? Okay, so children, we are just writing the same thing that we have written there while talking about the molecules. And here children, there are some substances, hydrogen, oxygen, nitrogen, ozone, phosphorus, sulfur. They are all elements for your information. And till here, okay, right, till sulfur. And you find the molecules. The molecule of hydrogen, I am writing it as H2, indicating that it is made up of 2 atoms of same element hydrogen. and here it's molecule of oxygen, molecule of nitrogen, made up of 2 atoms of nitrogen, oxygen. Okay, it is you can say a form of oxygen. Actually, it has 3 atoms of oxygen in it, in each molecule of ozone. Phosphorus, there are 4 atoms of phosphorus, and sulfur, there are 8 atoms of sulfur combining to form a molecule of sulfur. Now till here, that is acid. So these are all the molecules of the elements, and you see children, there is only one element, atoms of the same element. Also hydrogen molecule is formed one, atoms of hydrogen, and oxygen from oxygen atoms, and nitrogen molecule from nitrogen atoms, or ozone from oxygen atoms, phosphorus molecule from phosphorus atoms, sulfur molecule from sulfur atoms. So they are all molecules of elements, right? Okay, now we are talking about what is called atomicity. Atomicity is nothing but the number of atoms in a molecule. So the atomicity of the hydrogen is 2, because it has each molecule is having 2 atoms of hydrogen, right? Okay, what about the atomicity of oxygen? So you can find it is 2 again. And what about nitrogen? It's also 2, because each nitrogen molecule is made up of 2 atoms of nitrogen. And here, what is the atomicity of ozone? Ozone, the atomicity is 3, because each molecule of ozone is made up of 3 atoms. And phosphorus, its atomicity is 4, and that of sulfur, you find it is 8. Okay, good. And certainly these are all called as diatomic molecules. What are they? Diatomic molecules, right? Okay, good. Diatomic molecules. Now what about this? This is a triatomic molecule. The atomicity is 3. It is called as a triatomic molecule. This is tetraatomic molecule. Molecule. And then next, you observe these children, there are 8 atoms in each molecule of acid, so it's called as polyatomic molecule. Okay, good. Now let us see the molecules of compounds. So these are molecules of compounds. Why are they molecules of compounds? Because these molecules are made up of the atoms of different elements. Okay, that's it. Nitrogen, hydrogen, carbon, the oxygen. So they are all atoms of different elements combining to form molecules of these compounds. Okay, good. Now, how many atoms are there in the whole of each molecule of water? So you find 2 atoms of hydrogen and 1 atom of oxygen, that is 3. So it is a triatomic molecule. Triatomic molecule. And the next, coming to ammonia, it is atomicity is 4. It's a tetraatomic molecule. And the next, what about this one? Carbon dioxide is made up of 1 atom of carbon, 2 atoms of oxygen, so it's 3. It's a triatomic molecule. So children, right, we are talking about what is atomicity. What is atomicity? It is the number of atoms in a molecule. It's called as atomicity. And so here we see the atoms of the molecules of the elements and molecules of the compounds. So children, there are certain compounds which are formed not exactly, I should say, but they don't form molecules, but a gathering of a cluster of ions which are due to the ions, a cluster of ions, the oppositely charged ions, they combine and form such a large cluster, which are called as crystals, lattices, like sodium chloride, the next calcium chloride, magnesium sulfate, etc. So they're all formed by ions. What are ions? We have learned ions are charged particles. So how are they formed? They are formed by either loss of electrons or gain of electrons by atoms. So children, so these ions, they don't form molecules exactly, but a large conglomerate of ions together and form a compound. So children, we don't say that they are exactly molecules, but they are a large gathering of ions. They are compounds, but here the atoms are not directly involving by sharing of the electrons, but there is complete transfer of electrons between the atoms, resulting in formation of ions, and these ions form a large cluster forming of ionic compounds. So that is how certain other compounds are formed.